Welcome to Side Similarity Postulate podcast. So we've learned angle. Now let's learn side. It's kind of similar to side congruence postulate, but instead of our corresponding sides being congruent, they're going to be proportional. Right? So we always want to make sure that we find our statement of proportionality. So a statement of proportionality just matches up our corresponding sides. So if AB, in this case, AB to PQ, if that ratio is the same as BC to QR, is the same as CA to RP, our corresponding sides are in proportion, and therefore our triangles have to be similar. Only applies to triangles, can't use it with other figures, and we can think of rectangles, we can think of other figures. For instance, a rhombus and a square could have sides that are in proportion, since their sides are all the same, and they wouldn't be similar because they don't have the same angle measures. Doesn't work with triangles. If your sides are in proportion and you're a triangle, then you have to be similar. So if the corresponding sides of two triangles are proportional, then our two triangles are similar. We need to know all three sides to prove triangles similar using side similarity postulate. It is not enough to know only two. Right? Knowing 2 is fine if we were just looking for the scale factor and we already knew they were similar. But if we don't know they're similar, it has to be 3. Right? So if you don't know all three sides or can't find all three sides, then you can't use side triangle similarity postulate to prove similarity. Okay? And that's in your notes. Okay? That particular slide there, just showing you that particular information. So side similarity, if all three sides of a triangle are proportional to the corresponding sides of another triangle, then our two triangles are similar. All right, so here we have two triangles. When you're matching them up, you don't even have to think about which way they go. Just match up the sides. So I chose larger to smaller. It won't matter. There's not a pre-image and an image. We have to be consistent. Right? And just make sure you match up the smallest side in both triangles with the smallest side, and the medium side with the medium side, and the large with the large. Right? So I'm not going to match up, for instance, 21 in this larger triangle with the small side, 8 in the other triangle. Right? That's not going to work out. I have to match up 21 with 14, the largest side. The middle side is 18. 18 has to go with 12, and 12, the smallest side, has to go with 8. Right? So you're matching up small with small, medium with medium, and large with large. Right? So if we match our two smallest sides were 12 and 8, and if we reduce, we have 3 halves. Our two medium sides were 18 and 12. If we reduce, we have 3 halves. Our largest sides are 21 and 14. If we reduce, we have 3 halves. So because we have the exact same ratio for all 3 pairs of corresponding sides, these two triangles are similar. So determining if sides are in proportion. So which of the 3 triangles are similar? Did I put this one in your notes? I did. Just to make things interesting, actually, they are the way they are because that's how they fit on the paper. And they still work out fine, but for my lesson, I needed to go in a certain order. So if you go to the second page, underneath the 2 problems we already did, you will find this problem here. And I'm sorry there's not a whole lot of space, but there's probably, you can always attach an additional piece of paper. Use the back of the paper or something. So which of the 3 triangles are similar? I'm going to match up the sides in one triangle with the sides in another. Notice whichever triangle I pick, I have to be consistent and use the same triangle in the numerator and the same triangle in the denominator. So I chose ABC to be in the numerator for the first pair. We're going to look at ABC and QY, or XYZ, these two here. Right? So I chose ABC to be in the numerator and XYZ to be in the denominator. Right? And when I match them up, I go small with small, medium with medium, large with large. I don't worry about, how they look, which one looks like it goes with the other. If it's going to work, it's going to work with small, medium with medium, and large with large. And then you don't have to, think so much. Excuse me. All right, so in triangle ABC, the smallest side is 38. And in XYZ, the smallest side is 18. In ABC, and I'm going to put and equals for now. In ABC, the medium side is BC, and that's 42. And in XYZ, the medium side is 21. And in ABC, the largest side is 54. And in XYZ, the largest side is 27. All right, so now we're going to reduce. I can't tell anything with these fractions because they're not reduced. 38 and 18 are both divisible by 2. 38 divided by 2 is 19. 18 divided by 2 is 9. 42 and 21 are divisible by 7. But they're divisible by 3, too. Matter of fact, they're all divisible by 21. So 42 divided by 21 is 2. And 21 divided by 21 is 1. So 21 times 2 is 42. Well, I may as well figure out the last pair. 54 and 27, both divisible by 9. Anything else? So it would be 6 and, sorry, 27 times 2 is 54. It's a little late. I don't know if you can see the time on my computer. All right, so 54 divided by 27 is 2, and 27 divided by 1 is, 27 divided by 27 is 1. Well, those are not equal to one another, right? 19/9 is not equal to, does not equal to, right? So 2 out of 3 is not good enough. Has to be 3. So triangle ABC is not similar to triangle XYZ. And let's go to the next pair. So now we're going to work with ABC and QRP, or PQR, however I decided to write it. But anyway, it's these two triangles. And actually, it probably is supposed to be QRP, since that's what it says up there. And I have PQR. I guess I should fix that. QRP. All right, so again, match small with small, medium with medium, large with large, and ABC will be in the numerator again, and QRP will be in the denominator. So the small side on ABC is, again, 38. The small side on the QRP is 30. Medium side is 42. Medium side is 35. Large side is 54. Large side is 45. All right, 38 and 30 are divisible by 2. So that'd be 19 over 15. 42 and 35 are divisible by 7, and that would be 6/5. Well, may as well just do the last side for fun, but these aren't going to work out either. 54 and 45 divisible by 9, and that is 6/5. So again, all three sides are not in proportion. So poor triangle ABC is not similar to anybody. So triangle ABC is not similar to triangle QRP. All right, so that one didn't work out. Let's work with the last two. All right, so maybe none of these are similar. We'll work with these two now. So again, small with small, medium with medium, large with large. Triangle XYZ is going to be in the numerator, and triangle, I guess I really wanted it to be PQR. I wonder if it's written up there wrong. I don't know. Or maybe I just wrote it wrong down here. QRP. Anyhow. All right, so XYZ, the small side is 18. And the small side in the other triangle, whatever he is, QRP is 30. Medium sides are 21 and 35. And the large sides are 27 and 45. And now we'll reduce. So 18 and 30 are divisible by 6. That's the best we can do. So that would be 3/5. 21 and 35 are divisible by 7. And that would be 3/5. And 27 and 45 are divisible by 9. And that would be 3/5. So that one is true. We have a true statement of proportionality. True statement of proportionality here. So triangle XYZ is similar to triangle QRP. There we go. And we're done with this one. Okay? So you just need to match up all three pairs of corresponding sides and make sure they're in the same proportion. So move these guys over a little bit. Whoop. All right, let's go look at another problem now that I've made the page look a little nicer. And our last triangle congruence, triangle similarity postulate, and it's listed on the other page. I'm sorry, you have to flip back again. All right, so side angle side similarity postulate. This is the last one. There are only 3 similarity postulates for triangles and none for any other polygon. So there are 5 congruence, but just 3 similarity. Angle angle, side side side, which sounds a lot like side 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 triangle congruence, right? But instead of congruent, you're in proportion. And the last one is side angle side. And we know that it has to be 2 sides and the included angle, because we know that from working with congruent triangles. So if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the 2 sides including these angles are proportional, then the triangles are similar. So you have to have 2 sides in proportion, and the angle between those proportional sides has to be congruent. It can't be some other angle. All right? There's no side-side angle similarity postulate, just like there's no side-side angle congruence postulate. It has to be between. All right? So here, if angle x is congruent to angle m and zx to pm, so if we match up the ones that have a blue line next to them, the blue sides, and we get this, and we match up the red sides, and they're both in the exact same proportion, then our triangles have to be similar. Then triangle XYZ is similar to triangle MNP. All right, so we want to decide whether our triangles are similar. All right, well, we don't know 3 sides, so we can't use side, side, side anyhow. I'm going to write that down. We don't know the measures of 3 sides. So we can't use side, side, side triangle similarity postulate. Oops, yeah. Actually, instead of putting a similarity symbol there, I'm going to just write it out. Similarity postulate. All right, so we can't use side, side, side. But let's see about side, side angle. All right, so identify the congruent angles. Well, I guess I'll have the markings up there from earlier today. We have some 2 congruent angles, right? Angle LMP is congruent to angle OMN. And hopefully you saw, even without my markings there, that they are vertical angles. And vertical angles are always congruent. Now we need to check to see if our sides are in proportion. Oh, and I should check to see if this problem is in your notes. There's not too much left in your notes, actually. This is. So if you go back to the other page, let's look, I put all the problems on one page. This is the last problem in your notes besides the fill in there. All right, so check to see if our sides are in proportion. Remember, it's got to be small with small. And medium with medium. All right, and notice that those sides here, so this is the one I'm pairing up these sides and these sides that we know the measures of. Notice that this is the angle is between those 2 sides. So this is the included angle. Because if this was not the included angle, I would be stopping this problem. Because there'd be nothing more I could do. Because I have no more sides. All right. Sorry, that's not very easy to read, is it? I'll write that again. Included angle. There we go. All right, so I hate when it does that. Let's see if we're in proportion here. All right, so small with small, 4 has to go with 10. Oh, and by the way, make sure you stick to the same triangle in the numerator and denominator. I'm using triangle LMP in the numerator, and I'm using triangle OMN in the denominator. All right, so 4 over 10, and then we have medium with medium. So medium on LMP is 6, and that goes with the 15. And now we'll reduce to see if they have the exact same proportion. So 4 tenths, both divisible by 2, 2 fifths. 6 fifteenths, both divisible by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So yes, that checks out. They are in the same proportion. So we have two sides in proportion. We have the included angle. So I'll put two sides in the same proportion. And the included angles are congruent. So we can use side angle side similarity postulate. So triangle LMP is similar to triangle OMN. I made sure I matched up my corresponding parts using side angle side triangle similarity postulate. And there we go. All right, so this one does work out. Let's see if there are any more problems for us to do. Just the review. All right, so this is going to be the end of this podcast. Oh, actually, I have one more slide just to review through the three postulates one more time. So here they all are, all together, and they are on the bottom of the second page for you to fill out and do with me. So this is a great little review for you. So if two angles of one triangle are, we're going to fill in the blanks here, congruent is the missing word. To two angles of another triangle, then the triangles are similar. So here we have a picture, right? So angle T is congruent to angle M. That one is given. Actually, I'm going to move this down just a little bit. And we also know that, just move that a little bit more then, angle ULT is congruent to angle VLM. So notice I'm matching up the corresponding parts, right? I put T with M. I know they're congruent. I know the two L's are congruent because those are vertical angles. And they're always congruent. All right, so we've got two pairs, we have two corresponding congruent angles. So since there are two pairs of congruent corresponding angles, triangle ULT is similar to triangle VLM, and I need just a little bit more space. Maybe if I just scrunch these up just a little bit, everybody get real close together. Wish I could always do this on paper too. Using angle, angle, triangle, similarity postulate. There we go. There's the first one. All right, so all it takes is, and I should probably put 2 over here, 2 pairs of congruent angles to show that the triangles are similar. That's our first triangle similarity shortcut. Our second triangle similarity shortcut, actually the one we learned second is third in this list here, but we'll do the one we learned third, I guess, second. All right, so if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, they have to be in the same proportion, then the triangles are similar. Right? Sorry that the numbers are a little fuzzy here. I think they're much clearer on your notes. I put them in your notes first and I blew them up. All right, so let's find our congruent angle. Again, we have that angle congruent to that angle. Angle TUW is congruent to angle, what is that letter? So MUL, I think it's MUL. It is now anyway. To angle MUL, they're vertical angles. And now let's check to see if our sides are in proportion. So that was the first requirement. We have TU, so when we match again, we match small with small, medium with medium. And I'm going to put triangle TUW in the numerator and triangle MUL in the denominator. I tend to work left to right. All right, so let's see, we have 154. And 154, well, that's actually the large side. So 154 here has to go with the 70. I think that's 70. Yep, that's definitely 70. And the 132 has to go with the 60, because that's the smaller side, right? Small with small, medium with medium. All right? If you do it that way, you'll never mess it up. All right, so now let's reduce. Kind of help if this word corresponding wasn't so large. It's right in the middle of my way. Whoops, sorry. Here, we'll make that a little smaller, and then I'll scroll back if possible, since I accidentally made the screen larger, and I don't want to lose our work here. There we go. All right, so let's reduce. All right, so divisible by 7. Yes, I think. Yes. So the first two numbers are both divisible by 7. So let's reduce by 7. So 154 divided by 7, that would go in 20, right? So 14, and then another 2 times. Right? So 7 goes into 15 twice, and then I have one remainder, and 7 goes into 14 twice. So that will reduce to 22, and 70 divided by 2 is 70 divided by 7 is 10. Oh, so I could have actually divided by 2. I could make this 11/5. So not only is it divisible by 7, it must be divisible by 14. So 11/5 equals. All right, so let's divide 132 and 60. All right, so 132 is definitely divisible by 6. All right, so if I divide it by 6, 6 goes into 13 twice. And then I'd have one remainder. 6 goes into 12 twice. And 60 divided by 10 is going to give, by 6 is going to give us 10. Well, again, that will be 11/5. So I guess 132 and 60 were divisible by 20, not 24. It was 6 and 2, 12. Both divisible by 12. 12 is the answer. All right, so 11/5 equals 11/5. That checks out. So we have our triangles. Triangle TUW is similar to triangle MUL using side, angle, side, triangle, similarity postulate. And you will solve these the very same way. You are looking for the exact same information. Do you have two congruent angles? Two pairs of corresponding congruent angles? Then it's angle, angle. Do you have two sides of the angle between them? Then it's side, angle, side. And if what you have is 3 sides, you can use side, side, side. So if the corresponding sides of two triangles are similar, are proportional, then the triangles are similar. So we're going to match up our corresponding parts. And I'll just put triangle KPQ in the numerator. And I'll put triangle, I don't know which way this goes, KPQ, I think it's CBA. All right, so small with small. So KPQ small side is, what the heck are those numbers? I can see it on your notes. Looks like I got 72, 80, and 88. And the other triangle, 9, 10, and 11. You can see those. All right, so small with small, 72 with 9. Medium with medium, 80 with 10. And large with large, 88 with 11. All right, so 72 divided by 9 is 8. 80 divided by 10 is 8. 88 divided by 11 is 8. So notice they are all in the exact same proportion. So we now know that triangle KPQ is similar to triangle CBA using side, 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 triangle, similarity, postulate. And there we go. Actually, it's that one. Actually, the other two are theorems. Postulate and theorem just means that one was proved off of the other in pieces of information. So, but whether you call it postulate or theorem, it's okay. That as long as you know it's side, 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 angle, side, or angle, angle. I have a tendency to want to write the words postulate all the time. All right, so now we've gone over all three. One last little review. And we'll figure out if these ones are similar, and we'll review through them one more time. So, are the triangles similar? And explain. I don't think these ones are in your notes. Nope, so just follow along with me. I'll try and do it quick. Quickity quick. All right, so I've got an angle, right? I've got congruent angle. Okay, and let's match up our sides. And that congruent angle is between our known sides. So those are the ones we're working with. It is the included angle. So actually, I'm going to just write the words included angle. All right, so if these are going to be similar, it's going to be side, angle, side. So for our statement of proportionality, we're going to match up 5 is the small side with 2.5, the small side in the other triangle. 9 is the larger side, 4.5 is the larger side in the other triangle. When you have decimals, just multiply by however many places there are. So, multiply by each of the numerator and denominator by a power of 10 equal to how many places there are. Left off the word power of 10. So notice I have one decimal place, so I'm going to multiply by 10. If I had 2 decimal places, I'm going to multiply by 100. It'll clear out your decimals, and it's a lot easier to reduce. So 5 times 10 is 50. 2.5 times 10 is 25. That reduces to 2. 9 times 10 is 90. 4.5 times 10 is 45. That reduces to 2. That checks out. So our triangles are similar. I don't have a way to name them because there's no letters here. So the triangles are similar using side, angle, side, triangle, similarity theorem. How about the other ones? All right, well, we have the included angle, right? There we see we have a 90-degree angle. So we have a congruent angle, and it's the included angle. We have 2 sides. So let's see if we can use side, angle, side. Small with small, so that's going to be 3.2 goes with 1.6, and medium with medium or larger with larger. So 4.1 goes with 2.5. Multiply everything by 10 to get rid of the decimal. 32 over 16. Multiply by, did I say 10? Excuse me, by 10 to get rid of the decimal. Multiply by 10 again. 41 and 25. 32 over 16 reduces to 2. 41 and 25 does not reduce at all. So triangles are not similar, right? So we have to make sure that when they reduce, we have the exact same proportion. One last review through our 3 postulates. So we have angle, angle. 2 angles of one triangle are equal to 2 corresponding angles of the other triangle. The 2 triangles must be similar. Side, side, side. When 3 pairs of corresponding sides are in the same ratio, the 2 triangles must be similar. And then finally, side angle side. When two sides of one triangle are in the same ratio as the corresponding two sides in another triangle, and the angles between the two sides are congruent, the two triangles must be similar. So here are our only three options for proving triangles similar, our three similarity shortcuts. That is the end of this Nearpod. So now you're going to test yourself and see how well you understood this concept. All right? Just do your best. I'm looking to see how much you know and how much you've learned. All right? So bye for now.